Okay, the video ended abruptly, but I think we had finished the inductive reactance of L1. So we're about to do the inductive reactance of L2. So let's do the X of L formula. Good old 2 pi FL. So 2 times pi times frequency, which is 5K, and times L2, which is 60 millihenries. And remember, because we have milli and kilo, we don't have to worry about doing anything but doing the math, which is nice. So I'm going to clear my calculator, and I'm going to go to scientific, because pi, I could use 3.14. Let's do that. 2 times 3.14, which is what pi is, times 5 times 60 equals 1884. So that is in units. Now we have an answer that looks like that in K, and it is 1 point. Let me use a different color here because that doesn't show up too well. So that is 1.88 K ohms. So if we take this, our decimal place is actually right here right now. I don't know why I highlighted the comma. I guess because I saw it, so let's undo that. Our decimal is right here. Remember, to convert to K, we have to divide by 1,000 because K means multiply by 1,000. So if we move it 3 places, 1, well, that just looks bad too. Again, apologize, but I'm trying to get used to the pen. Takes a little while, and the pad is actually smaller than the screen, so it takes a little getting used to. 1, 2, 3. So if we put the decimal there, we arrive at 1.88K. So that is no doubt our answer just based on, and sorry for drawing on the screen, but I did. So we'll click that, and sure enough, that's right. So I'm going to clear the screen, and we're going to see what else the world has to offer. So this is a different example here. This is just showing you the relationship of frequency to our X of L. As we increase frequency, our X of L goes up. And not hard to see that at 1 kilohertz, X of L is 188.4 ohms, with everything staying the same, 30 millihenry, and of course 2 and pi are constants. So if we increase frequency, we increase X of L, and it is directly proportional. So nothing hard about that, because that X of L equation is all multiplication. So if a number gets 5 times higher, the outcome is going to be 5 times higher. So pretty simple to understand that, I think. And here it's just showing that if we change our coils, if they go higher, we went from a 30 to a 60, then we also increase our X of L. Again, simple multiplication equation, nothing hard about that, and we do increase. So I think that's pretty clear as well. So now we're asked to do the total inductive reactance in this circuit. Now again, we can do this 1 or 2 ways. I'm going to go ahead and do the reciprocal formula. So I'm going to clear my calculator, and I'm going to say 30, which is L1 reciprocal, plus 60 reciprocal, equals, and I'm going to reciprocate that. So our total equivalent of L, so LT, I guess, for lack of a better descriptor, these two in parallel are L1 in parallel with L2. That equals 20 millihenries. Don't know how my color got so odd. Let's see if we can change that back. There we go. So when we calculate that, that's pretty easy. It's one total inductive reactance. So we have to take 2 pi FL of that. I'm not going to keep writing the formula. It's going to write it out. 2 times pi times times L, and this combined L is 20 millihenries. So we're going to do the math on that. And I don't know why my pen is staying such an odd color, but we'll find out here in a moment. So let's go over to our calculator. Let's clear it. Let's say 2 times, again, pi is 3.14 rounded, times 5, which is our frequency, times 20, which is our millihenries, and we come out with 628 ohms, and there it is. So nothing hard there either. It's just a matter of doing the math. We did have K, we did have milli, so we end up in units. So hopefully that's definitely getting clear by now. So we'll click on 628, and sure enough, we are correct. Okay, if the circuit contains inductors only, other circuit values are calculated using Ohm's law. So you need to write these formulas down. To get IT, we simply divide E by our X of LT. To get the I, the current of each individual one, we calculate that by using X of L of each inductor. So very straightforward. Just make sure you remember that. And we're going to work some examples. So I've got a 5 in parallel with 15. Both of them are henries. Hertz are in 60, so we're already in base units, so we can use just whole numbers without having to worry about any prefixes as far as the metric system is concerned. So let's go ahead and reciprocate 5 and 15 and get this value. 5 reciprocal plus 15 reciprocal equals, and reciprocate that. So we get 3.75 henries. Now I wanted to show you this little question mark down here. Anytime you need help, those are down there. So we found L total, which is what we just done, and this will give you some insight into what you need to be doing. So just wanted to make sure you're using that question mark anytime you have questions. So L total equals 3.75 henries. So now we've got to get X of L to get what that total current is. So that's what it's asking for. It's not asking for individual currents. It's asking for total. So that's why we went ahead and got our total inductance. So 2 pi FL, again, I'm not going to put that formula down. We should know it by now. 2, let me clear my calculator and make sure we're absolutely clear. 2 times 3.14 times 60, which is our frequency, times 3.75 equals. So we come out with 1,413 ohms. So easy enough there. So I'm going to write that down. 1,413 ohms. So now we have our X of L, so it's just a matter of dividing that into our voltage, because if you wrote that formula down, you see that IT equals E over X of L T. So this was X of LT because we used the LT value in our X of L. So let's do the math. We got 120 volts. Let's clear our calculator. 120 divided by 1,413 equals, and this is in regular units here, so this is amps. If we want to convert to milliamps, we got to multiply it by 1,000, which basically means we move that decimal place over 3 places, and then this becomes milliamps. 1, 2, 3, 84.9 milliamps is our answer. So we've got it right here. So let's click it and see if we're right. Yes, we are. So now it's asking for the current through L1. Now, we've got total current, but we haven't done our individual X of L's so that we can find out individual current. So that's the very first thing we're going to have to do. So we're going to have to figure out x of L1, and we're going to have to figure out x of L2. So we've got to come up with that ohmic value, that impedance that these guys have, so that we can calculate current through these things. So again, it's 2 pi FL. I'm going to go ahead and do something over here. I'm going to store pi in memory, 3.14, and I'm going to store that in memory. So now pi is in memory, and I can just hit the MR button to use pi. That way I don't have to type it in every time. That's just a little handy feature that most modern calculators have today. So I'm going to clear my calculator, and I'm going to say 2 times, remember reminder, and it didn't work. There it went, equals, whoops. Alright, maybe we're just going to type pi in. 2 times 3.14 times, and x of L1, well, we're 10 kilohertz, times 10, oops, times 10, dang nabbit, times 10, times 10, equals. So if you take a look, we did 2 times pi times 10 kilohertz, which was our frequency, times 10 millihenries, which was our L1, and we arrived at 628 ohms. So I'm going to write that down here. Whoops, in the wrong spot. Now we're going to do x of L2. We're going to say 2 times 3.14, which is pi, times, and we're going to do 10,000 hertz, or 10 kilohertz in units, 10K, times 20 equals. And that doesn't look right, so I'm going to clear that. I probably pressed a button wrong. 2 times 3.14 times 10 kilohertz times 20 millihenries, 1256. That looks a little better because I knew this was double, so it should come out to double what the first one was, and so that makes a little more sense. 1256 ohms. Now remember, the E of L formula, or excuse me, the I of L formula is equal to the voltage, which in this case is 10 volts, divided by the X of L. So we're going to start with 628 ohms, which is what L1 is, and we're going to do that math. So we're going to say 10 divided by 628 equals, and that's going to be in amps, so we've got to move the decimal place 3 places. So 1, bring up my marker here, 1, 2, 3. Well, that's not coming out right at all, so must have messed up somewhere. So let's see where we went astray. And this can happen sometimes, so I'm going to pause the video for a moment and come back and figure out what exactly took place that didn't work right. Okay, I realize what's wrong with this one, so we're almost out of time, so I'm going to end this video and we're going to start in the next. Bottom line, I thought we were continuing with a previous example and we weren't, so we're going to start all over from scratch in the next video for this one.